standard form, we get y double prime minus 1 times y prime plus 1 over x times y equals 0. We obviously see x equals 0 as a singular point, and it is the regular singular point as we use the method to verify it. So it's the regular singular point. Then the solution, the power series solution, will be y equals Cn, no, summation Cn x minus 0, which is x to the power n plus r, n from 0 to infinity. So then we have y prime as the derivative of the previous series, or as the Cn multiplied by n plus r times x to the power n plus r minus 1, and y double prime as the summation n equals 0 to infinity Cn n plus r times n plus r minus 1 times x to the n plus r minus 2. Okay. So same routine. We replace each term with the power series. So the differential equation, the first one like x multiplied by the summation for the y double prime, or the Cn, n plus r times n plus r minus 1 times x to the n plus r minus 2, n from 0 to infinity. Second term, x times summation Cn, n plus r, x to the n plus r minus 1, n from 0 to infinity. And the last one is the summation of Cn, x to the power n plus r, n from 0 to infinity equals 0. The first two summations, there is x as an extra factor. So adjust it by multiplying x into each term. So then the power of the x gonna be added by one more. So the first one, the power of the x becomes n plus r minus 1. And the second term, summation Cn, n plus r, x to the n plus r, because minus 1 plus 1 becomes adding by 0. And the last one, Cn, x to the n plus r, n from 0 to infinity equals 0. So x to the power r multiplied by the summation Cn, n plus r times n plus r minus 1, x to the power n minus 1, n from 0 to infinity, minus summation Cn, n plus r, x to the power n, n from 0 to infinity, plus summation Cn, x to the power n, n from 0 to infinity equals 0. Get x to the power r out of the way, and this is not 0. And then work on adjusting the power to be the same. Like this, the last one, let k be n, so no change. The second term is similar, so let k be n, no change. But the first one, we let k be n minus 1. Then the k plus 1 equals n. And then the index of the first summation, if n start at 0, k start at negative 1. Subscript n, that means subscript k plus 1. N plus r becomes k plus r plus 1. N plus r minus 1 becomes k plus r. X to the power k as a common k now, minus summation k equals n and k are the same. Now no change. Just replace k with the n. Similar to the last summation. Okay. Start at 0, 0, start at negative 1. So we have one extra term that comes out from the first summation. So as k equals negative 1, we get the term c negative 1 plus 1, or c0. K negative 1 So becomes -1 plus r plus 1 or just r. And the second factor that becomes r minus 1 times x to the power negative first. That's an additional term. And then the rest, now they have the common summation, k from 0 to infinity, with the factor x to the power k for all three terms. Now gather them together as ck plus 1, k plus r plus 1 times k plus r minus ck, k plus r plus ck equals 0. The initial condition from the initial equation from the lowest power of the x, which is -1, initial equation is r times r minus 1 equals 0. Because the coefficient C0, we assume is not 0. So r times r minus 1, or the equation of the r, is already in the factor form. It's nice. Then we get the r equals 0 and r equals 1. And this case, r1 and r2. r2 minus r1 equals 1, which is the positive integer. Going to be case 2. And set it aside. While the group here will give us the recurrence relation as ck plus 1 times k plus r plus 1 times k plus r minus ck k plus r plus ck equals 0. Again, we are solving for the higher index. Then we have ck plus 1 equals, move the ck factor over to the right hand side. We get the quantity k plus r minus 1 multiplied by ck. Because subtract means when you add both sides, so the k plus r going to be positive. Plus 1 on the left becomes minus 1 on the right. And both of them have the common coefficient ck. So gather them as a coefficient of the ck equals k plus r minus 1. And all divided by the coefficient of ck plus 1, or the factor k plus r plus 1 times k plus r. And this recurrence relation is the general form for both r's for k greater than or equal to 0. Recurrence relation. Okay. So r equals 0, r equals 1, and ck plus 1 equals k plus r minus 1 times ck divided by k plus r plus 1 times k plus r for k greater than or equal to 0.